Have you ever looked up at the moon and wondered what it would be like to live there? For decades, it's been the stuff of science fiction. But what if I told you that we're on the cusp of making it a reality, thanks to something you might have on your desk right now, a 3D printer? It sounds wild, but building habitats on the moon using 3D printing isn't just a cool idea. It's a practical solution to one of the biggest challenges of space exploration. So, how would it even work? You can't just ship a giant printer to the moon and press go, right? Well, it's a bit more complex, but the basic principle is the same. The first major hurdle is what to build with. Launching materials from Earth is incredibly expensive. It costs thousands of dollars just to send a single pound of anything into space. Building a whole lunar base with Earth materials would cost billions, if not trillions. This is where the moon itself becomes our construction yard. The lunar surface is covered in a layer of fine dust and rock called regolith, and this regolith is the magic ingredient. Scientists have discovered that lunar regolith can be melted down and used as a kind of ink for a massive 3D printer. Imagine a rover-like printer armed with a powerful laser or microwave emitter. It would crawl across the lunar surface, scooping up regolith, melting it at super high temperatures, round 1,600 degrees Celsius, and then depositing it layer by layer to build up walls, domes, and other structures. The process is called sintering. By precisely melting the regolith, we can fuse the particles together into a solid ceramic-like material that's incredibly strong. We wouldn't even need to add any binding agents. The moon provides everything we need. Think of it like building a sandcastle, but instead of using water to hold the sand together, you're using a super-powered laser to turn it into rock. What would these lunar homes look like? They probably won't have big bay windows. The moon has no atmosphere to protect it from harsh radiation, extreme temperature swings from scorching hot to freezing cold, and the constant threat of micrometeorite impacts. So, the designs being tested look more like igloos or hobbit holes. These dome-shaped or partially underground structures are incredibly efficient. The curved walls are great at handling the internal pressure needed for a breathable atmosphere, and covering them with a thick layer of loose regolith adds a fantastic layer of natural insulation and protection. So, what's the timeline? This isn't happening next week, but agencies like NASA and the European Space Agency are actively funding and developing this technology. Projects like NASA's Project Olympus are working with companies to design and test prototypes of these lunar printers. The first missions might involve sending smaller printers to test the concept, building landing pads or simple shelters for equipment. As the technology matures, we could see entire habitats being printed, ready and waiting for astronauts to arrive. This approach completely changes the game for long-term space colonization. It moves us from just visiting the moon to actually living there sustainably. By using local resources, a process called insight to resource utilization, we dramatically cut down on costs and our reliance on Earth. We could build labs, living quarters, and even greenhouses, all printed from the very ground we stand on. It's the ultimate form of off-grid living. The dream of a moon base is closer than ever before, and it's being built, or rather printed, one dusty layer at a time. This technology could be the key that unlocks not just the moon, but maybe Mars and beyond. What do you think? Would you want to live in a 3D printed house on the moon? Let me know down in the comments. Thanks so much for watching. If you enjoyed this cosmic journey, don't forget to hit that like button and subscribe for more adventures into the future. See you in the next one.